Have you ever wondered how something as destructive as a tornado can form from just air and water vapor? Picture this: a colossal funnel of wind, spiraling at a terrifying speed, ripping through landscapes with an unfathomable force. This is a tornado, one of nature's most destructive phenomena, yet also a marvel of atmospheric science. Tornadoes possess an enigmatic charm. On one hand, they're incredibly destructive, leaving trails of devastation in their wake. On the other hand, they're fascinating subjects of scientific inquiry, where air and water vapor, elements so basic, so commonplace, come together to create a spectacle of such raw power and intensity. So, what are the mechanics behind these mesmerizing cyclones? How does our atmosphere concoct these swirling giants? Well, the answer lies in a complex interplay of weather patterns, wind shears, and pressure systems. But don't worry, we'll break down this intricate process for you. Stay with us as we unravel the science behind the formation of tornadoes. To understand tornadoes, first we need to grasp the basic principles of weather patterns. Weather patterns are intricate dances of atmospheric elements, choreographed by nature's laws. At the heart of these patterns lie three pivotal players: air pressure, temperature, and humidity. Air pressure, the weight of the air surrounding us, is a key influencer of weather. When pressure is high, air is being pushed down, often leading to clear skies and calm weather. However, when pressure is low, air rises, forming clouds and potentially precipitation. Now let's talk about temperature. It's no surprise that this plays a crucial role in weather formation. Warm air tends to rise, and as it ascends, it cools and can form clouds. This process, known as convection, is a fundamental driver of weather. On the flip side, cooler air tends to sink, often resulting in clear skies. Finally, we have humidity, the measure of moisture in the air. When humidity is high, the air is laden with water vapor. As this moist air rises and cools, it can form clouds and eventually precipitation. These three elements, air pressure, temperature, and humidity, constantly interact in a dynamic dance, shaping the weather patterns we experience. For instance, a sunny, warm day may suddenly turn stormy if a low-pressure system moves in, bringing with it cool, moist air. Where do tornadoes come into play? Well, these severe weather phenomena often form within unique weather patterns known as supercells. These are large, powerful thunderstorms characterized by intense rotating updrafts. The formation of a supercell requires specific conditions, including significant changes in wind speed and direction with height, known as wind shear, along with ample moisture and instability in the atmosphere. So, the next time you're watching a weather forecast, remember that behind those moving graphics and percentages lies a complex dance of atmospheric elements. Understanding these dynamics is crucial in predicting and preparing for severe weather events, including the formidable tornado. These variations in weather patterns serve as the initial stage for the birth of a tornado. Now that we understand weather patterns, we can move on to the formation of tornadoes. Tornadoes, those swirling vortexes of wind and debris, are born from the womb of severe thunderstorms. But not just any thunderstorm has the power to create a tornado. It takes a specific kind of storm, one that has the perfect blend of ingredients to give birth to such a powerful phenomenon. Let's dive into the mechanics of this. Picture a severe thunderstorm. It's characterized by its intense updrafts and downdrafts. Updrafts are columns of warm, moist air that rise upwards, while downdrafts are cooler, drier air that falls downwards. This movement of air creates a sort of atmospheric tug-of-war. Now imagine this. The warm updrafts, like ambitious climbers, ascend rapidly into the storm, carrying with them a large amount of moisture. As they rise, they cool and condense, forming those towering thunderclouds we often associate with a brewing storm. On the other hand, the downdrafts, like weary travelers, descend rapidly, bringing with them cooler, drier air. This cool air, being heavier, pushes against the warm updrafts, causing a spiraling effect. This is where the magic happens. The constant clash between the rising updrafts and the descending downdrafts creates a vortex of rotating air, a sort of spinning column that reaches from the thunderstorm down towards the ground. This spinning column, ladies and gentlemen, is the embryo of a tornado. However, this spinning column alone does not a tornado make. It's only when conditions are just right, when the updrafts are strong enough to sustain this rotation and the downdrafts are intense enough to enhance it, that the spinning column can mature into a full-fledged tornado. The formation of a tornado, thus, is a delicate balancing act. It's the perfect storm, a rare combination of updrafts and downdrafts, of heat and cold, of moisture and dryness. This violent interaction between updrafts and downdrafts is the first step in the formation of a tornado. It's a dance of nature, a ballet of the skies, choreographed by the forces of the atmosphere. The result, one of nature's most awe-inspiring yet terrifying performances. Wind shear plays a critical role in the formation of tornadoes. As we delve into the heart of tornado mechanics, we come across this pivotal player, wind shear. But what exactly is wind shear? In simple terms, it's a difference in wind speed or direction over a relatively short distance in the atmosphere. Imagine being on a highway. The cars in the left lane are driving at 70 miles per hour, while those in the right lane are only moving at 50. This difference in speed is a bit like wind shear, but happening up in the sky. Now, wind shear can occur on different planes, either horizontally or vertically. Horizontal wind shear occurs when wind speed changes with height above the Earth's surface. It's like climbing a mountain and feeling the wind grow stronger with each step you ascend. On the other hand, vertical wind shear is when the wind changes direction or speed at different altitudes. Picture a giant invisible corkscrew spiraling up into the sky. This twisting motion can give birth to the rotation we observe in tornadoes. So, how does wind shear contribute to the formation of tornadoes? Well, when warm, moist air at the surface and cooler, drier air above start to interact, the variation in wind speed and direction creates a rolling motion of air. This is the horizontal wind shear. Under certain conditions, a powerful updraft can tilt this horizontally rotating air into a vertical orientation. This is where vertical wind shear steps in, facilitating the creation of a rotating storm system, or what we call a supercell. It's like a ballet in the sky, a dance between the forces of nature, resulting in something both beautiful and terrifying. This supercell is the breeding ground for tornadoes. It's within these rotating storms that the intense funnel of a tornado can drop down and touch the ground, wreaking havoc on everything in its path. So you see, without wind shear, a rotating storm system, which is the precursor to a tornado, would not form. It's a crucial cog in the complex machine that is tornado formation, and understanding it brings us one step closer to unraveling the mysteries of these incredible weather phenomena. The final stage in the formation of a tornado is the touchdown. This is the climactic moment when the swirling mass of air reaches the surface of the Earth, marking the birth of a full-fledged tornado. But how does this happen? How does a tornado descend from the sky to touch the ground? Well, it all starts with the rotating storm system high above the Earth's surface. This rotating storm, known as a mesocyclone, is the precursor to a tornado. As the mesocyclone intensifies, it begins to form a rotating column of air that extends downwards, creating the initial funnel cloud. This funnel cloud is not a tornado yet. It's more like a tornado in the making. For it to become a tornado, it needs to touch the ground. But why does it descend? What makes it want to reach out and touch the Earth's surface? The answer lies in the difference in pressure. The pressure at the ground level is higher than the pressure inside the funnel. This difference in pressure creates a suction effect, pulling the funnel cloud downwards. The funnel cloud descends, inching closer and closer to the ground until it finally makes contact, creating a tornado. But that's not all. The formation of the tornado funnel is also influenced by the surrounding air. The air surrounding the funnel cloud is cooler and denser than the air inside the funnel. This cooler, denser air pushes against the sides of the funnel, helping to narrow and elongate it, further contributing to its descent towards the ground. As the funnel cloud descends, it continues to pull in warm, moist air from its surroundings, fueling its growth and intensifying its rotation. The funnel becomes narrower and longer, transforming into the iconic, terrifying tornado shape that we all recognize. And then, finally, it happens. The funnel touches the ground, and a tornado is born. It stands tall and menacing, a swirling, destructive force of nature. The touchdown is complete. With touchdown, the tornado is now fully formed and ready to unleash its destructive power. The tornado has arrived, and nothing can stand in its way. We've journeyed through the birth and formation of a tornado. Let's recap the main points. We started by unraveling the enigma of tornadoes, these extraordinary and destructive forces of nature that have fascinated and terrified us for centuries. We learned that a tornado, at its core, is a rapidly rotating column of air in contact with both the surface of the Earth and a cumulonimbus cloud, or in rare cases, the base of a cumulus cloud. We then dived into the world of weather patterns, understanding how they play a crucial role in setting the stage for tornadoes. We discovered that tornadoes are most likely to form in supercell thunderstorms, the strongest and most severe of all thunderstorms. It's within these intense storms that the conditions become ripe for the birth of a tornado. Speaking of birth, we delved into the process of tornado formation, a complex and intricate dance between air pressure, temperature, and humidity. We learned that the creation of a tornado requires a precise combination of a warm, moist air mass colliding with a cooler, dry one. This collision results in an updraft that can spawn a tornado if the conditions are just right. Next, we explored the role of wind shear, a change in wind speed or direction over a short distance, in contributing to the rotation and longevity of a tornado. Wind shear, it turns out, is a key player in the formation and sustenance of these captivating yet destructive phenomena. And finally, we witnessed the tornado touchdown, the moment when all these elements converge and the tornado makes contact with the ground, often leaving a path of devastation in its wake. But why does all this matter? Why is understanding the mechanics of tornado formation so important? The answer is simple. Predicting and preparing for these destructive phenomena can potentially save lives and property. The more we understand about these processes, the better our chances of predicting when and where a tornado might strike. This knowledge gives us the power to warn communities in the path of a tornado, allowing them to take shelter and reduce the risk of harm. Furthermore, understanding the science behind tornadoes can also help us better design buildings and infrastructure to withstand the powerful winds of a tornado, potentially preventing significant property damage. In conclusion, while tornadoes may be a destructive force of nature, they are also a fascinating testament to the power and intricacy of our planet's weather systems. By delving into the science behind these phenomena, we not only gain a greater appreciation for the natural world, but we also equip ourselves with the knowledge to protect ourselves and our communities. By understanding the mechanics behind tornadoes, we can better predict and prepare for them, potentially saving lives and property. Stay curious, stay informed, and keep exploring the wonders of our planet. If you enjoyed the video, please consider liking and subscribing, as it helps our channel grow and continue to create new and interesting content. We encourage you to express your thoughts on the video in the comments and share our content with others.